Hello everyone, and welcome to our last video, our last lesson of the year. Our last lesson is going to be to discuss misleading graphs and statistics. So we're just going to learn how to recognize misleading graphs and statistics, which is something that's really useful with everything that's being presented to us in the media. So we're first going to take a look at graphs. Graphs can be used to influence how people see data. So the way that it's presented or the way that data is displayed can influence how people interpret that data. In problem number 1, we're shown a graph that shows the size of tomatoes after being treated with 4 different fertilizers, A, B, C, and D. And as we look at this graph right now, it looks like there's a big difference between the height of all of these bars. So it looks like there's a big difference between the height of bar B, so that's fertilizer B, and bar D. But if we take a closer look, you can see that this graph is actually really misleading. So our first task is to explain why this graph is misleading. Well, let's take a look at that y-axis. What number do we start at down there? We start at 80. We start at 80 and we end up at 86. We normally start graphs at 0, but here we're starting way up near almost our top number. So our values here actually only range in 6 or less from each other. So when we start our graph at a value that's not 0, we're really being misleading. We should at least point out that this is not starting at 0. And our second question is, what might someone believe because of this graph? Well, if you look at this graph, it looks like one of the fertilizers is a lot better than the others. It looks like D has the most growth for the tomato plants. But actually, D is only about 85.5, while the rest of them are hovering around 84 to 82 grams. That's not much of a difference. So it looks like here that somebody might believe that there's a big difference between these fertilizers. There's really not. The second problem gives us another graph. This one is about average gas prices every September. So our x-axis gives us years, and our y-axis gives us how much gas costs. Now if we take a look at this, it looks like there's a very steep incline that happens between 1995 and 1997. And for the most part, the rest of this graph is pretty level. But if we take a look, it's actually really misleading. So let's explain why this graph is misleading. Let's take another look at that y-axis again. Now, for one thing, it does start at $1. It doesn't start at 0. But the main thing here is that our intervals are not constant. So we jump from $1 to 110, thinking that maybe we're going up by tens each time, going up by 10 cents. But then we jump up to 112 from 110. So suddenly we're going up by 2 cents. So the jump isn't the same. And it goes up by 2 cents all the way up until 120. And then all of a sudden it jumps up by 20 cents each time. So we go up to 140 and then 160. That's not good. This is a little bit misleading because that scale is not constant. B, what might someone believe because of this graph? Well, let's take another look at that curve. This whole big jump between 1995 and 1997, that's actually only 14 cents. So I'm going to label this interval right here with 14 cents, just so I can remember that. Now let's take a look at the jump between 1997 and 2001. It doesn't look like it goes up that much, but it actually goes up by 19 cents. That's more than this jump. So this little jump right here is 19 cents. This graph is misleading because those two intervals are not consistent. Our 19 cents should be way longer than that 14 cents. In addition to the way that graphs can be misleading, statistics can also be misleading. So statistics can be misleading because of the way data is collected, so this is collected here, or the way that results are reported. So in order to combat these misleading results, we want to have a large random sample size, or a large random sample. So what I mean by that is that a large sample includes a lot of different data points so that we can make sure that our generalization, or whatever we're reporting, is indicative of a large population. And we want a random sample because imagine if you interviewed one certain type of people. If you interviewed one certain type of people, they're going to give you pretty biased answers. So a random sample is a sample of a ton of different kinds of people or of data that'll give you something that's unbiased. Okay, number 3 tells us, a researcher asks 4 people if they have seasonal allergies. 3 of them respond yes. We have to explain why this next quote is misleading. The researcher says, 75% of people, or 75% of the population, have seasonal allergies. Why is this misleading? Let's take another look at that sample size. That sample size is 4. Remember what we need for a good data sample. We need a large random sample. Well, 4 people is not that large. Also, 3 of those people responded yes. While it is possible that 75% of the population has seasonal allergies, it's a little bit unlikely. So to be sure, we want to have a large sample, maybe 100 or more, to get a good, accurate prediction of how many people have seasonal allergies. All right, our 4th problem tells us that a researcher surveys people entering a wildlife reserve about what they like to do in their free time. So we have to explain why this quote is misleading. The researcher says 90% of people like to watch birds in their free time. All right, why might this be misleading? Well, let's take a look at that sample again. We're not told the sample size, so we're going to assume the best. We're going to assume that it's a large sample. But this researcher surveyed people entering a wildlife reserve. So the people who are entering a wildlife reserve, what do you think those people like to do in their free time? They might be interested in nature, right? He's not interviewing the people who are sitting on their couch watching TV. So this researcher didn't really get a random sample. They got a sample of the people entering a wildlife reserve. So it's not surprising that 90% of those people might like to watch birds in their free time. But that's not indicative of the larger population. So the issue here is with the people that this researcher interviewed. And we need to have a random sample for our results to be unbiased. All right, this concludes our final video. I want to thank you all for putting in such hard effort this entire year, and I want to thank you for watching these videos. You all are awesome. You've put in amazing work, and I know you'll do great things. Have confidence in yourselves and go forth. Also, don't forget those problems at the bottom of your guided notes.